So let's find angles given different situations. So let's say on this one we were told that triangle BEC is a 90-degree angle. So, or a right triangle. So we know that this angle is 90 degrees. If we're given that triangle CED, so CED is also a right triangle, we know that that's 90 degrees. And triangle DAB is a right triangle, so that's 90 degrees. So let's say that's the info we're given with the side lengths. And we want to find the missing sides. So the first thing, we'll need to find this side, and that side. So let's find this total side first. Well, since this is a right triangle, we know using the Pythagorean theorem that 8 squared plus 10 squared equals this whole length, or BD squared. Well, 8 squared is 64, and 10 squared is 100. So the square root of 164 is not quite a nice number, so we could leave this one of two ways. We could say the square root of 164 for the whole length, or we can say that's approximately 12.81. So this whole length is approximately 12.81. Well, now, if we want to find this other value right here, we have this triangle going on. We know that 9 squared, or 81, is equal to 5 squared, 25, plus BE squared. I'm going to move my paper over so we can see this whole equation. So 81 minus 25 gives us 56. And square rooting that is also not a nice number, but to get us approximation, we can say BE is either equal to the square root of 56 or approximately 7.48. So if we know that this whole length is 12.81 and we know this segment is 7.48, then we also know that the other small segment is 5.33. So we're going to find sides using angles, using the fact that this is using angles. Using the fact that these are right triangles. Well, one last side to find. Well, if this is a right triangle, we can say that 5 squared plus 5.33 squared equals the side DC squared, which is this side. So 25 plus 5.33 squared gives us 28.41 equals DC squared. So DC is equal to either the square root of 53.41, which is approximately equal to 7.31. So this side is 7.31 approximately. So we can find sides using angles, especially if it's things like right triangles. Also, for example, if we're given something like this as a diagram, let's say we're given that ECF is equal to 3x plus 9. We're given that CF bisects this entire angle. So that means this whole thing is 3x plus 9 as well. We also know that FCD is equal, so this whole thing as well, is equal to 4x minus 18. And we want to find FCE, so we want to find this little angle. Well, we can use the fact that these two things are equal to find x first. So we can say 3x plus 9 is equal to 4x minus 18. So if we add 18 over, we get 4x equals 3x plus 27. Subtract 3x from both sides, and we end up with x equal to 27. So what that means is if we plug 27 to either one of these, we'll get this entire angle, and since this is equal to this, these two things are equal because this ray bisects this angle, we'll know what this angle is. So let's just put it into 3x plus 9. So in other words, 3 times 27 plus 9. Well, 3 times 27 is 81, plus 9 is 90. So this whole thing forms a 90-degree angle. Or in other words, 4x minus 18, 4 times 27 minus 18, also gives me 90 degrees. So this angle itself is a 90-degree angle. So this quite isn't drawn to scale, but this scenario would be matched if x was equal to 27 and our whole angle was equal to 90.